Okay, 6.5, solving polynomial equations. Here are the things that we will be doing. We're going to review factoring methods, GCF, MA, which means we'll be multiplying A and C, and also grouping. And then we're going to use a new method, which are going to go over at a later date. And then right now what we're going to go over is factoring MA with substitution on higher degrees. So here is a problem completely worked out using MA with substitution. So here's our problem. X squared minus 10x on the square root of x plus 21 equal to 0. So over here on your right is where you decide how we get x from the square root of x. So you're going to be looking at your middle term and your first term. And you decide what part of your middle term can you square to get your first term. So we say, can we square the square root of x to get x? Yes, you can. And here's where you do substitution, and you need to get used to this so that it backs up what you're going to do in pre-calculus and in calculus, which for a lot of you, you're going to go on and you will have to use, take some sort of class like that in college. Anyway, so we let u equal to the square root of x. And when we say we're going to do that, and we substitute it in, you see that on the second step. So if u equals the square root of x, that means where you see the square root of x, you see u. And if the square root of x is u, and then we substitute that up here where we see the square root of x, and then we square it, that means we have u squared. So up here in the front we have u squared minus 10u plus 21 equals 0. And so we go on and we complete our MA method. So we have this 1 in the front times 21. So we have factors of 21 that add up to negative 10, which would be your negative 3 to negative 7. We go on and complete this MA. So we take out the GCF u squared and 3u, which is u, and the GCF of negative 7 and 21, which is negative 7. And so that we have u minus 3 in common in both of those sets. And so we can take out u and negative 7 so that we have these two factors, u minus 3, u minus 7. And at this point, we go back in and replace that u, which we had originally set equal to the square root of x. And so now this u minus 3, I missed my subtraction sign, is the square root of x minus 3. And we have the square root of x minus 7. Equal to 0. And remember, we have these two are now two small equations. And so what we have going on here is if we solve those, we have the square root of x is now equal to positive 3 because we had to move that over to the other side to solve it because that was equal to 0. And then we now have square root of x is equal to 7. I want to get rid of that square root. To do that, I square both sides. And so now I have just x. 3 squared would be 9. My square root of x is gone again over here on this side. And the square of 7 is 49. And so here are two answers for this problem. Not every substitution problem is only going to have two answers. It does for this problem. Let's see another solving with substitution, how that comes out. Explain how the graph of a polynomial function will help you factor a polynomial. Let's see this one. If I have something to the 4th power, I know that I can possibly at most have 4 real zeros. So 1, 2, 3, 4 times it could cross the x-axis, meaning I'll have 4 solutions. So maybe at the end I'll have 4 solutions, so that would be a check for us. If I look in my middle term, is there any part of 27x squared that will give me 9x to the 4th? Well, think of what are factors of 27. You can divide, it's 3 times 9. I think those are the only things I can come up with. If I do 3x squared, can I square that and get 9x to the 4th? Yes. And I can check, like the 9x squared to get 9x to the 4th. No, that didn't work. So you're checking factors of that middle term to see if you square it. Can you get that front term? Yes. So since this happens, I set this part inside, which I was able to square to get my front term equal to u and replace that here on the inside. So remember, 3 times 9 was 27. So what times this is going to give me that 27? Aha, 9 is separate from this that's equal to u, so I have 9u. All of this is replaced because I'm squaring this right here to get that 9x to the fourth. So all of this is u squared. So as I solve this, I end up with u minus 5 and u minus 4. There are steps that are skipped here, which means I have u equals 5 and u equals 4. So I've gone about this slightly differently, and I can replace at this point u with my 3x squared, because that's what u is. And I have 3x squared is equal to 5, and 3x squared is equal to 4. And then I need to get x by itself. I'm dividing by 3 in both of these cases. And now I need to get rid of the x squared. I have to take square roots. So I'm square rooting both sides. There's some rationalization that's going to go on here, so we will have to go through and review some rationalization. But this is what it looks like. And remember, when we square root, you always have two answers. You have a positive and a negative. So I also have a positive and negative here. That means I have 4 solutions. I have 1, 2 here, 1, 2 here, 4 zeros. I have 4 possibilities of having 4 zeros. So that's a check. And then we're going to go on and we're going to do, can I write this in quadratic form? So we're going to be using that substitution kind of method in writing this in quadratic form. So again, you'll be breaking up parts of 40 into the fourth, and can that go in and be squared to give you 150 into the eighth? So let's take a look at that problem. If you decide that 8 times 5 is 40, let's see, if I square 5 into the fourth, look at that. Oh, I get 25 into the eighth. Does 25 go into 150? 25 times 6 gives you 150. Because remember, this 5 into the fourth squared. 5 squared is 25. That's what they want you to see here. And so this is writing it in quadratic form. This is where you will stop with these problems. They're not solving it. They just want you to write it in quadratic form. So, and instead of actually putting a u in, they want to see what are you squaring to get this into quadratic form. So it's a step shorter than the full substitution. And we're going to work through this and answer questions when you come back in tomorrow. So what is substitution? Where do I begin with the u? Where do I place it in? And remember, we're going to use that graph to know how many zeros am I looking for, how many solutions am I looking for. So we have that maximum possible. That'll let you know how many solutions that you have.